Lesson 17.2 Entropy and the second law of thermodynamics. So, firstly, we're going to need to understand how entropy changes. Entropy increases from states of matter, as mentioned previously, increases from temperature. For gases, increases with volume and decreases with pressure. It also increases after dissolving. And as you move down in the periodic table, it increases. It increases with compounds that are structurally more complex, such as how C6H12O6, which is glucose, has more entropy than H2O. It increases when there are more moles of gas in the products than in the reactions, and decreases with separation. In this question, they ask us to predict the sign of delta S for each of the following and explain why. In A, they ask us for the evaporation of alcohol, suggesting that it's going from a liquid to a gas. We all know that gases have more entropy than liquids, so the delta S here would be positive. Freezing of water, which goes from liquid to solid, decreases the entropy because entropy of solids is less than the entropy of liquids. Compressing an ideal gas at constant temperature. So we know that for gases, and specifically gases, decreasing volume, which in other words compressing it, decreases the delta S. So here the delta S would be negative. Heating an ideal gas at a constant pressure. This is also a gas, so we can apply we this is also a gas, so we know that heating it will result in an increase in entropy. Dissolving NaCl in water, NaCl also known as salt, and we know that dissolving also increases entropy. For the final part of this lesson, we're going to be explaining the second law of thermodynamics, which states that any spontaneous reaction increases the entropy of the universe, meaning the entropy of the universe is always increasing, which tells us that both delta S of the system and delta S of the surrounding can be positive at the same time, and thus it will result in a spontaneous reaction. This rule can also be read as if delta S is negative, then the reaction is non-spontaneous, and if delta S of the universe is positive, then the reaction will be spontaneous. Okay, in this question, they ask us to predict whether the reaction will be spontaneous or not from the given values. In A, we have the delta S of the universe given as a positive. So we know that the reaction is spontaneous because delta S is greater than 0. In the second one, they give us the opposite, which delta S of the universe is equal to a negative value. So this would be non-spontaneous because the delta S is less than 0. Here they gave us the delta S of the surrounding and the delta S of the system. Knowing the laws of thermodynamics, we have the equation of delta S of the universe is equal to delta S of the system plus the delta S of the surrounding. So we will get a positive value, meaning that this reaction is in fact spontaneous.
That'll be it for lesson 17.2, relative entropy of substances. If you have any questions or want to ask anything at all, you can ask it down below in the comments or in the server. If you want more tutorials and videos like these, you can find them in the channel. And yeah, enjoy them.